Yeah, so thanks for joining. I see a couple familiar faces in the room here. And so the idea of today is maybe a short presentation, hitting a couple points, and then open it up if you have questions. Maybe you're early in your journey around computational design. Maybe it's specific to a platform. Maybe you just have general questions. Maybe you have very specific questions. So we encourage you to ask any of those questions when we get to that period of time. So for the agenda, we're going to start off with a what and why. We always like to kind of level set so that everyone in the room kind of knows what applied software, what Donnell and I mean when we say computational design. Touch on a little bit the importance of strategy. We'll talk a little bit about some tool demonstrations, just to highlight a handful of exercises. Some of the exercises we're going to look at are MEP focused, but when you look at that, we'll talk about how it can be applied to other disciplines. So we wanted to create some variety here. And then finally, we'll end with that Q&A session, which really should be, a kind of a bulk of our time. So when we start and we talk about what computational design is, this is the first thing we tell everyone when we do these presentations or we have meetings. And it's a way to sort of explain, our methodology and thought process behind this. And so we consider computational design a problem-solving methodology that we apply to design. And we wanted to simplify the definition. You'll find thousands of definitions out there that are not, they're all right, none of them are wrong. But we wanted something that was a little more open, and it didn't put us in sort of in a box of what it had to be. So we really take cues from this idea of computational thinking, where computational thinking involves these 4 steps. And when you look at these steps and you think about what these actually are saying, you realize that you may use this methodology to solve problems even in your personal life, at home, wherever it may be. But it's kind of clouded under this nebulous term of computational design. So the very first thing we do is this idea of break a big thing into parts. So that's decomposition. So we take a big problem, break it into parts. We'll see some exercises later about how we might, construct a project from scratch using some of those components. We look for similarities and patterns across all of those parts and start to sort of petition them off as things that we want to tackle. We look at the next part, abstraction, is really this idea of really just focus on what's important. A lot of us may have spent time trying to automate something, and we spent a whole lot of efforts doing it just to realize we're not getting the benefit on the back end, or it just wasn't worth it. So focus on the important aspects of these things. And then that last thing is this idea of creating step-by-step instructions. And that's where we'll use what's called visual programming. In all the examples we see today, it'll be Dynamo, could be Grasshopper, there's a bunch of others, but really it's just those step-by-step instructions to create those, to solve that problem. The next thing we always want to say, just to kind of, make sure we're on the same page, is the idea of why computational design. And so we believe pretty strongly in this top line here about how it can help us achieve better business outcomes through productivity gains, efficiency increases, and overall better designs. And we always kind of touch on these 3 big topics. When we look at efficiency, that's where we, immediately go to things like automating repetitive tasks. Really what we're trying to do there is increase the value of our utilization by automating those tasks, being able to take on more items, more things, do more things, really creating more time. And the goal by creating time, yes, it equates to money, but it gives us the ability to put that time towards what maybe brought us into the industry, whether it's being a project architect or being a structural engineer. We didn't necessarily want to spend all that effort doing a lot of those mundane tasks. What we want to do is doing those design things. So, how do we build efficiency into that? Quality. Another big thing why we want to tackle computational design is this idea of how can we use that tool to pursue better design solutions. It may be through simulation, it may be through analysis, it may simply just be creating more design options, but we're focusing on better design quality. And that last one is the idea of growth. Traditionally what we would say is this is accomplish more with less. And recently I came across, the fact that has a negative connotation. We're not trying to replace anyone when we do this. So how do we accomplish more with what we have? So that's the big goal. And how do we grow from that? And the hope is the growth side takes into account efficiency, takes into account quality, ultimately, hopefully leading to larger projects, more complex projects, and building towards generating more work. Now, the last little thing before we look at some examples is this idea of strategy. And, we put this nugget up here just to illustrate the importance of why we want to build a strategy around computational design. In business, we're used to having potentially IT strategy or finance strategy or business development strategies. So it makes sense that you would also have one around computational design and how you want to implement it. A strategy is a fundamental pattern of present and planned objectives. We look at things of resource management, we look at interactions within the organization, with competitors, environment, all of those things we need to take into account. And we ask ourselves, some big questions: what, where, and how. Why are we pursuing computational design as a problem-solving methodology? What's the point? What are we trying to achieve? What are our goals and objectives? And we believe pretty strongly you want to identify those, because without, we don't have the opportunity or may not see the full benefits of what we can realize through computational design. I could be creating one of these things in a silo, and the firm doesn't benefit from it. There were times Donnell and I worked together previously before this, and I built some things that he had already built and I didn't know it. That's just wasted time. And so how do we make sure that what we're doing is sustainable and can continue to grow? And we do these through workshops and strategy roadmaps, whether Applied Software is hosting these or you do these on your own. We encourage you to come together as a team, whether it's with us or another third party or just yourselves, and ask these questions and build out these roadmaps. The last couple of things I want to go through is just some demonstrations of various tool examples, and then we'll just open up and have a discussion and see what questions people may have or thoughts or any of those things. This first example is going to be looking at a project startup tool, and I'll kind of run through this in a second. But the idea here is, and you'll see this in a lot of other examples, is how do we leverage something like Excel, a medium that we're very comfortable with, that almost everyone in the firm is comfortable with? How do we leverage something like that to facilitate the creation of a project? And so what we'll see here is a couple things. One, we're looking at this template that's been developed. So, we have an Excel template with a whole bunch of sheets that have been created or that we want to create. We include information about their title blocks. We include information about the levels and the views that may be associated with those sheets. And then information about those views as well, like view templates and view types. So, we have this kind of master file that we can build from. And then once we get into, and I'll click through some of this, but once we get into our project, what we're illustrating here in this demo is how do we, actually first, let me show you this, is how can we leverage external projects? We call them container files, for instance, but how can we leverage external projects to bring information in, okay? So what we're highlighting here is the ribbon that we've created using some of these third-party plugins and developing simple UIs. Now, here's an example of how are we going to choose a project type. A lot of our firms that we work with in the industry work on different project typologies. So how do you choose a different type? Creating that or pathing to that legend that we've created, that template, we can specify a number of levels and floors between the heights between those floors, and we can run it. And so what this example is going to do is it's going to launch that Excel file. It's going to go pull that data back in. So it's going to go look for those container files that we've talked about. You may get a handful of pop-ups here and there, but it's going to create all those views. It's going to create the sheets. It's going to place views on sheets, and it's even going to bring details in. So as we kind of look through here in the project browser, we'll start to see these are all the views that were brought into this project. So from the very beginning, we hit File New, we path to a series of things, and now we have all our views created. We have our details brought in, and then what we'll see as well once we get through here a little bit is we have our sheets that have been created. They log themselves where they need to go. You see some of those actually have views put on them, and that matches what was in that Excel file. And then we'll even look at one of the detail sheets here that have been created, and you'll see all the different details that have been populated in this document. Very quickly, we're able to start a project, right? And that can expand all disciplines. All disciplines have variations of creating views and sheets, creating details. The next example is a similar example. The next example is a similar example, but here is just to kind of illustrate, maybe at a deep dive into an MEP workflow, is how can we use that same methodology of an Excel template to drive the creation of, in this case, actual levels. Before, we weren't creating levels through Excel. This one, we're going to see how we can create levels through Excel. So let me go ahead and click through here. You'll see here we have just some basic views, basic levels, and in our Excel template, similar things. But here now we're actually inputting elevations. Now, let me pause it there real quick. Between these two examples, we can start to see what kind of flexibility we want to build into a tool. One tool, you could only choose a dimension between levels. So for instance, I could say I want 5 levels, 11 feet apart, and that's what that example was. Here's another iteration of the same process, but how do we build flexibility into a tool? Okay, so these are things that you want to consider. So for this example, the end result is going to be the same. We're going to create views, and we're going to create levels, add an elevation, but here you can see through specifying level names and elevations, we can actually drive a higher level of customization. Okay, so granted, the result's going to be the same. You know, as we click through here, we'll see we're going to path to that Excel file and we're going to run it. But what we'll see is in the end result, we have our levels, no different than the example before. We have our views, very similar to the example before. But how do we build functionality into our tool? You know, things to consider. So when you're building a tool like this, a lot of customers want to start with, say, a project startup. You need to start to ask yourself, what are the requirements of this tool? Donnell's in meetings all the time where he has these conversations, and we talk about, you know, what do you need the tool to do? What does the user need to be able to input? If the first example, you just said, I just need a way to create 10 levels at a certain amount of feet, we're golden, you know, go for it. That we could do that. But if you say, well, you know, I see Geo's on the line here, and you know, I've seen a lot of their projects, and maybe the first couple levels are a certain height, and then everything above that is another height. Okay, well, how do we build that flexibility into a tool? So think about those type of things so that we can decide, you know, what medium are we going to leverage? Are we going to use Excel for more of those things? Are we going to use a UI that a end user would interact with and make that a little more accessible for them? In this last example, before actually, I guess maybe 2 examples. This example here is to really illustrate this concept of leveraging linked data. Now, what we're going to see in this example, this is very specific to MEP, but you know, I keep an open mind about how you can apply this elsewhere. Is how do we use, in this case, we're using Dynamo. So all these examples have been Dynamo. How do we leverage Dynamo to look at a linked element? So in this case, we're going to have a linked architecture model. So those walls we see in the background, those are all out of the linked element, or you know, a linked architecture model. Those tags that you see there, those are simply room tags coming from that linked model. So how do we take linked data and first off read it? So be able to actually say, okay, in that model, you have 4 rooms. Those 4 rooms have these parameters, a room name and a number and a location. Okay, so we have that information. So we kind of leave that sitting there. And then the next thing we say is, all right, well, what we're actually aiming to do here is create MEP spaces. And we want to be able to match where they are, the name and the number, just for consistency's sake. And we want to automatically place those. Okay, so what we'll do is we'll kind of click through this example and see how this is going to work, and we can kind of talk over it a little bit. But again, you know, right now we're talking about pulling room data and creating MEP spaces, but we could just as easily be looking at pulling walls from another project, or pulling doors from another project, and actually pulling that information into ours. So again, as I mentioned, we're looking at a linked model. We're looking at rooms that are in that space. Now, we won't dive into the specifics of the Python node, but we'll talk a little bit about what that's doing. So in the very beginning here, what we're going to do is we're taking in an input. So what that Python script is going to do is it's going to look for the linked model. Once it finds that, I have it listed, okay? Then from there, we can look at very specific elements. We can find all of the rooms that are in that linked model. So I go through and I say, okay, get all of the rooms. Now there's 4 rooms. Then from there, I say, okay, now that I have the rooms, I want you to get the names of the rooms and the numbers of the rooms. And I also want you to get where they're located. So all of the rooms that we place in Revit, and areas and spaces for that matter, have a location point. And you probably noticed, like when you go to automatically tag a room, or you select a room, wherever the center of that X is, sometimes it gets moved around, but wherever the center of the X is, Revit's reading that as the center location point. So what the Python node is going to do in the front end, it's going to find the graph, or it's going to find the link. It's going to find the rooms in the link. It's going to find information about the rooms, the name, the number, and the location. Once you have those three pieces of information, we can then create spaces. So in that same Python node, we go through and create spaces. And we can do this just by looking in the Revit API and understanding how to create those things and what information is needed. Once we make those, it then passes through, and then we'll see here, and we'll also be able to create a tag for it and actually place that tag. Now we could probably put all of this in one little Python node in the front, but I kind of split it up. So I run this off the screen. You see those things pop up, and those are the spaces. So I'll select it here, and you can see it's a space. It has the same information as that next to it. Okay, so if we're building out a tool, maybe it's a startup tool. We start at the very beginning that we talked about. We could start to look at how do we combine some of these things. And a lot of times when I'm building, and I know Donnell may have different ways that he handles it, but if you came to me and said, hey, we're really looking at building a project startup tool. Say we're an MEP engineer, for example. We're looking to build a project startup tool, and these are the 10 things that we do manually on every single project. Every single project, we link in an architecture model. We copy monitor the grids or the levels, or we create the levels. We create views, and we create sheets, and we copy the spaces and where we make spaces. These are all the different components that make up starting a project. How can we automate that? And so that's the big problem. The big problem is project startup. We said, okay, now break it into parts, and we isolated that we have the link in a project. We have the level creation. We have the spaces, the sheets. All of those are the parts. Then we look at the patterns, and we say, okay, well, one pattern may be we're pulling a lot of information from that linked model. Maybe we're pulling information about rooms and levels, and we want to kind of break that off as a piece that we want to build, and we want to use that just to collect data from a linked model. And then maybe there's another part of it that, hey, we're creating a lot of things. We're creating a lot of views and sheets, and they all kind of fall under a specific category. So that's another part that we can focus on. We focus on those as the important things, and then we build those step-by-step instructions, whether it's in Python or in Dynamo. Those are building those instructions. And sometimes what we'll do, or what I'll do, is I take all those parts and I try to get one part at a time to work really well. So maybe earlier today I was building something to link in a architecture model and copy all the levels of it. Okay, well, that's one piece. Let's get that working. Once I know that that works, then the next thing may be, let's look at creating levels or creating views from those levels. And you just kind of, work your way through. Okay. So those were really just a handful of tools that we wanted to share, just something to kind of spark some thought and some, get you thinking a little bit. The big takeaways from those would be not necessarily, I don't do MEP or I don't do architecture or structure, none of that matters. It's more just thinking about, what is a problem that you have in your day-to-day, you spend a lot of time on. And more importantly, you spend a lot of time on every project. And then you start to think, okay, are there ways that we can automate that, or even aspects of that? And it's easier on the back end of creating views and sheets. Those are kind of the low-hanging fruits of things that we start to look at. And then we say, okay, well, we saw examples of how we were able to copy rooms out of a linked model. What else can we copy out of a linked model? What other information can we pull from those if we need to be able to create those things? So just to give you a little bit to think about, I encourage everyone now, if you have questions about some of the things we just looked at, you have just general questions, you have very specific questions, the time is yours. And if you don't have anything, we don't necessarily have to keep you hostage. We just want to open it up to everyone else. You could chat too if you'd rather chat. I see Alex is chatting. Great anticipation here. Copy opening from linked model. Yeah, I mean, that's another example of, and there's things you have to, there's things you have to test when you're doing this. So for instance, if we were looking at copying and opening from a linked model, one, what is that opening? Is it a family? Is it a wall opening? Is it a cased opening? Not just it's an opening, but what it actually has been used to create it. And then how we go about doing this is, one, we have to see what's possible, right? We always go to, for instance, API docs, okay? So there are certain things that we just don't have the ability to create. So before 2021, maybe, we couldn't create ceilings, right? We weren't able to create ceilings. So we have to first dive in and say, okay, can we create wall openings? Well, one, if we're able to find it and specify or see it in a linked model and we can create it, we can copy it over. Other things that we have to consider, and Donnell, you may know specifically about wall openings. I kind of think we can't create wall openings specifically, but with wall openings, one of the ways that I look at doing is, okay, well, if the wall opening tool isn't accessible to us through something like Dynamo, what if we're using things like a family to create a wall opening? Those are very much able to copy over, and leveraging elements like that to be able to pull through. So when we're talking about copying elements, there's always things that we have to go through. Some things we just can't do. Wall openings, Donnell, you may know. I have to go look. I don't think wall openings we can actually copy.
Wall opening is going to be hard because you need it's hosted to a wall. So in order for you to copy a wall opening, you have to copy the wall and all these openings into it to get into your model. So if you just say, I have my existing one, I want the openings there, then it's not as easy as just copying. It's more of bringing in that information and trying to input it correctly on your wall than it is just a pure copy.
And creating, yeah. So, Alex, if we said, hey, like, this is what I'm trying to do. First thing we would want to do is, can we find it in the API? Like, is wall opening something that is accessible? And if we find it that it's something that we can create, then what most likely we would do is, it's not just a copy, but it's pull the information from it. So get the location, the height, the host, and then recreate it. If it's a family that's hosted to a wall, it may be a matter of copying the wall, pulling the wall in with the host. And it's not without headache. I mentioned I was looking at linking in a project earlier. Before that, what I was doing was trying to copy a whole model using Python, pull a whole model from a background into another project. And what I found is the sequence of copying is something that I had to work through. I just grabbed all the elements and copied. And what I realized what was happening was I would copy all the doors before I copied all the walls. So when the door came in, there was nothing to host to. So those are things that we have to kind of open ourselves up to and think, is there a sequencing we have to consider? Can we copy, or do we have to recreate? Does the API allow us to do that? I'm currently working through a process where I place detail groups with their insertion points at exactly the intersection of a reference plane and a level in a section view. You and I can talk about this later offline, Christopher, but could you say if you've done something like this before? So with detail groups, I'm pretty sure, yes, we can place them. If we have the reference point, and we have to figure out how we want to go about doing that. So short answer is, can it be done? Yes. Have I done it? Not necessarily, but we can look at it for sure. What things we'd want to look at doing is, do we want to grab all of the reference planes in the project? And do we have a way of filtering just the ones you need versus not? And we can always pull out intersections. And so, for instance, in Dynamo, we can create planes in Dynamo. We can grab levels. We can grab reference views or reference planes. We can find intersecting geometry. We can do all of those things to find the points. So that's the easy part. The hard part then becomes, what do we use as a way of filtering? So it may be, there's a name for the reference plane that we use that we can grab. Maybe it's you actually physically select them, and once you do that, it finds everywhere there's an intersection. So yeah, that's definitely something that we could look at doing for sure. Do you have any comments on that, Donnell, about kind of grabbing geometry out of a project, looking for intersections, and then placing other elements? Caught him while I was on mute. Any other questions? So yeah, Geo, reach out. We can talk and see where it's relevant, but it's very much possible. And some of the things too, to think about when you're looking at, we're kind of talking about Dynamo just because it's here, but it's very relevant. Is the first thing I always check before I start diving into Dynamo is, can I do it in Revit manually? So there are some things that we would like to, so this is a good example. I wanted to be able to, earlier today, this was my thought process. So I mentioned that I was trying to open a very, very large model in the background, and I wanted to copy all of that geometry into a project. And my first test took 2 hours and I quit. It just, wasn't going to be relevant. So the next thing that I said was, okay, well, what about, let me see if I can pull Revit up. What about the concept of binding a link? Okay, so let me link in a project real quick and I can kind of talk through this. And this is kind of how I would go about doing really any of these things when we're saying, hey, is this possible? So I have this project here, and I'm going to link in a project. So let's just link in this sample project here. This one's pretty small. We'll just link this one. Okay, so this is what I've been working on. This is an internal thing where we use this for our learning and development. And we're looking at how we can take these models and pull them into, say a customer template, right? Just as an example. So the copy, and you can see this is a very large project. This is what we use for all of our training. It's a large model, 10,000 elements, takes a lot to copy in, okay? So that didn't work. And this kind of touches on even Alex's question about, wall openings or even geos, is this possible? So the next thing I said was, well, that didn't work, but I know you can bind a link out manually in Revit. So out of the box, we can bind a link and it turns it into a group. Can I do something there? So it's like, okay, that kind of makes some sense. Maybe that's another way to do this. So the steps would be link in, which I can do in Revit, and then bind the link, which I could do in Revit. Let me see if that's possible. So when we're doing something like that, and we're looking at something that's going to be programmatic, not just the nodes that Dynamo offers, but we're going to have to dig into the API a little bit. We come to Revit API Docs, incredibly helpful website, have it up probably all the time. I know Donnell does. And I just started kind of looking around at, I searched binding, see if there was something there. And I noticed that none of these had any relevance to what I was trying to do. I looked up Revit link instance because I know what I'm going to be dealing with is a Revit link. And so when you go into Revit link instance, and if you've ever been in the API, you kind of, a lot of them are broken down by this. We have the class, which is the top line here. And then there's typically members, methods, and properties. And I'm not going to pretend to understand everything, but my thought process was, I know I can do it manually. Let me see. And so I dug through here, and there was nothing that said bind link. Didn't seem to be feasible. From here, I then go to trusty Google and start to Google bind the link in Revit API and all these things. And lo and behold, for that specifically, we don't have access to it. It's been a wish list for a long time. Maybe we do, maybe we don't. So then at that point, it's like, well, now I need to come up with something else. And I've worked through other ways of doing that. And so that's really the steps to take is, whenever you come up with anything, once you get past like, hey, I want to create a sheet, or hey, I want to do this, one, can you just manually do it in Revit? If you can, that's a good step. If you can't, chances are you're not gonna be able to do it programmatically. So can I do it manually? And then start digging into, say, the API. Do I have access to it? I mentioned ceilings was one that I always thought was kind of silly. For a long time, you could create floors and roofs, but you couldn't create ceilings programmatically. Well, in my opinion, they're all the exact same. They just maybe changed location. Whatever reason, we couldn't for ceilings. And they finally opened it up where that was available. So this does get updated over time. But those are, a few tips that I would encourage when you're kind of going through that process.
To explain what those members and methods are really quick, think of a class like, let's say, a human being, or let's say a male, let's say Chris, right? Chris is a human being, and then the members, the method members is kind of tricky because it depends if it has other things inside of it. But the one thing you really want to notice about is the method. The methods is, let's say, things you can do with Chris. So one thing like walk. So walk would be a method for Chris because you want Chris to walk, right? And then a property is something that's kind of embedded or something about Chris. So you can say, if you type in Chris Brown hair, it'll say Brown, so like that. So that's kind of how these pull out. So one is going to do something, and the other one's going to just tell you some information about it. In properties within Revit, they all don't allow you to change it, but some do. So something like a boundary box. If you type in, let's say you have an instant link name dot bounding box, it'll just give you the bounding box so you have it and you can use it. While if you go something like toString, and you can tell the difference because you gotta have parentheses between them. So you'll say, Revit link dot toString, and then the open and close parentheses, and then that will change whatever it is into a string for you to see it. So that's kind of how to think about them.
I think somebody came off mute. Maybe on accident. Nope, it was accident. Any other questions? Again, the office hour intent is give you a little bit, just some tips and tricks and examples. And then if you have questions, we encourage you. If not, free to go. Gio, you can ping me later and we can look through how to do that. What is the detail group you're trying to place? And you can come off mute if you want.
Can you hear me?
Yep.
Yeah, so we're just talking about this in our team, actually. When we got to document a wall section, it is very easy to very quickly generate a rough wall section when if all we have is that reference plane representing the edge of stud, which is what we use as a benchmark or a datum, and the horizontal levels. And with a preset library of detail groups that represent, for instance, a slab condition, a typical residential building floor condition, we could very quickly generate that wall section with, I would hope, just a push of a button to say, this is this kind of a wall, and it would know what detail group to grab and where it goes. That's kind of where I was going with that question and with that process. If that makes sense.
No, it does. And I think the simple answer is we come up with something. We'd have to, but it would be a hard task. We'd have to look at things to help us identify like what's the detailed group. Maybe it's based on something in the view. A good example is I did a proof of concept for someone else that was an idea I had where if I have a 3D view, and it kind of touches on that idea of pulling in details. We looked at that in the beginning, an example of pulling in details. So I tried an example of this. Imagine I have a 3D view, and in that 3D view, I have three things. I have a brick wall that has a certain makeup, a door, and a window. And within each one of those, I've associated a keynote to specify some conduct division something in my keynote schedule. Okay, and so what I did was imagine I had a brick wall and I associated I did two keynotes. I did a primary and a secondary. So primary, I just said brick. So imagine I don't know, it's like 0421 something. And then say I had a metal and I had an 054 as my secondary, because maybe those are the main things that make up that, knowing there's other stuff. The window I associated like an 08 number, and the door I associated an 08, I guess, or 07. So each one of those elements had a primary and a secondary, and that was in a 3D view. I then took a test detail library project with a handful of details, and each one of those details also had a primary and secondary associated with it. Same thing, keynote. So maybe I had a window sill detail that primary was window, secondary was brick, or whatever it may be. And so I had those as two separate entities. And then what the Dynamo-Graph did, and this was just an example to see if it was possible, and we might be able to build on this, is look at what's in my view. So in my case, it was 3D view. Look at what's in the view and grab all the elements. And then go grab the detail project and bring in any details that have any of the keynotes that you see in that 3D view. And then it pulled it in. And, it was starting to build on how do we quickly pull details from a library based on our model. So I suspect we could potentially start to look at something similar. I mean, there'd be a lot more involved, I think, but maybe there's something in the view that helps us identify what type of detail component is or detail group, and we kind of go through that. Any thoughts on that,
Yeah.
Donnell?
Yeah, I think I was yeah, that sounds like a good way to go. I think my initial thought was maybe making it a family, because the family, you can better define the exact reference points to that, so it's easier to place.
No, I think that's a good point too.
Because I think the detail group, because the detail group is whatever you want. The way Revit will do it is basically do a bounding box around the whole object, and then the very middle of that whole object is going to be where your base point is, and now you got to base everything off of that, which can get complicated in trying to figure out where that edge is.
No, that's a good point. And maybe something we consider, Gio, is how to, is it detail groups versus a family? A family has a very exact origin point. A detail group, if something got added to that detail group, that bounding box expands, that placement point expands. Not impossible. I mean, you can find the center, and then you have to do gymnastics to get to a corner. But the high level, yeah, we could definitely do something. We'd have to dive into a couple of things. How do we call it a detail group or family? How do we know it goes with what? And then we start to look at, how does it get placed and where does it go? And, who knows? It may be something as simple, and I don't know if this would work if it was a family, or because we can't do this in a project. If it was a family, you could have like an invisible line potentially that could be called like level, or, something to help us find ways of snapping to levels in the project.
Yeah, I like that idea.
But definitely possible. And there's an attractiveness of the group. There's also one about the family. We just have to figure out what actually works for what we're trying to achieve, and I'm sure we can come up with a solution for either.